Let's see. At least we have a worksheet that gets to blinking. We'll focus on this. Okay, so today we'll continue talking about mineral nutrition, but now more we talked how things are informed. So now, how do they actually get in and out of the cells? So before we move into that, great. Just last class, some of you were asking about mycorrhizae, and I knew I had a picture that I think is coming. I think it's like lecture 29 or something. And I knew I had this picture of a fossil, and I said 50 million years ago, but it's actually over 400 million years. And it's a fossil from early Devonian, and they think this that is coming in a minute looks pretty similar to the mycorrhizae that we now see. This is just going to be terrible. Let me see what can we do. Well, let's just move on. I will tell you what I was going to tell you later. Let's move on to class. So I'll show you this later. Okay, so we're going to be talking about solute transport. And so for solute transport, how things get in and out of cells. So we're thinking about membrane transport proteins. So we have things, typically bilayer, then the phospholipids, which are the main components of the bilayer, are going to have the polar groups facing the hydrophilic environments in and out of the cell, and then the hydrophobic lipids towards the interior. And then many of the transport proteins we're going to be talking about are fully transmembrane proteins, so you will see them fully outside of one side of the membrane, proteins to the other side of the membrane. And so, because then that they will help move solutes from one side of the cell into the other. I have no idea. So, let's get
All right. Figure out how to do this.
This is just which was like this one. Oh, like one or two. So I had some. No, like the exams too. I had Peter. That's what was literally. Oh yeah, he's literally. I was like, you go to class. I think that's what it is. You have the new guy. You have the new, see like the guy that comes with his cats. How you have it? Everyone was telling me about that. I was like, yeah, like he wears a shirt of his cat every day. Like so many shirts with his cat on. What? I was like, sorry, this is the physics professor. Like every like my
so put the request later on. So let me try to get to something that we can actually do without paying too much attention. I'll teach this another time. Let's focus on this. the actual portion. I'm glad we actually talked about it. Anyways, okay, so let's focus on this. So you've probably heard about, so the goal is we're talking about active transport and passive transport. Okay. So if you remember, whenever we talk about channels, because we're going to be talking about ions are moved either by channels or by pumps. Channels, just remember, channels only work by diffusion. So they have to have a concentration rate. What does that mean? That if you have a cell, you have a cell, and you're trying to get these ions through using a channel, then your concentration gradient has to be favorable, right? Higher here, lower here, and then you can use a channel. Even if you have a channel, even if the channel is open, whatever is happening, if the concentration gradient is unfavorable, nothing is going to be moved through the channel. If you want to move this ion out of the cell, then you would have to use some kind of pump that will consume energy to move it against the concentration. So that's what we're going to be talking about today in solute. So one of the important things is, so we're going to basically determine how plant cells move different ions in or out, depending on the concentration gradient that is present on a particular ion. So let's just briefly review membrane potential, because that's an important thing. What can you tell me about membrane potential in general? Okay, let's see. What can you tell me about membrane potential? Not just plant cells. I mean, I know you've heard that before. Yes.
Is it more negative on the inside? than the
Yes.
outside?
So it's basically the voltage difference. So basically how you determine is you can measure in voltage to a voltage meter, and then you would basically measure voltage outside of the cell, and then inside of the cell, and then the difference between voltage is membrane potential, and cells tend to be more negative on the inside. That's true for neurons. That's what allows all of the active. Sorry, this has to be distracted. I think I need it. That's what allows action potentials to occur, and this is what and so one of the other things that we talked about before is basically how okay, so how does the membrane potential relate to all of these that we're talking about, active transport and passive transport? Then it basically tells you, or remember that when we're talking about ions, it's not just the concentration of ions, but also the charge, right? So when you're trying to move ions, you don't just have to consider, well, is sodium higher outside than inside, I can move it in, but because the interior of the cell or the exterior of the cell already has a charge, then you're also moving more positive charges. If we're talking about sodium, if you're trying to get it out, you're like pumping out some positive charges, so the interior is going to become more negative in that sense. So you have probably heard about the Nernst equation before, and I'm so glad to look into this, because at least we can do that today. So what can you tell me about Nernst equation, Nernst potential, anything about that? What do you know about that?
You'd use it to calculate the potential for a cell membrane.
Yeah, so basically that's what allows to tell you, well, in this case, we're going to use it to calculate and determine how things are moving in and out. Is it passive diffusion? Is it passive diffusion or is it active transport? But basically, the Nernst equation tells you the ion concentration across the membrane when things are negative. Okay, so we will calculate that. You're going to see how hopefully I can explain to you without those slides. And then we will, by calculating the Nernst potential, we will determine if an ion, a specific ion, is entering the cell by passive diffusion or if it requires active transport. Okay, so we just do this again. Yes, nobody's working today.
I usually cut it down. And then like the millimeter centimeter, but that's close. I know, it feels so weird now.
Yeah. It gets those 6 moves like that.
That and then like once you get to like a certain level, it feels like that. You know,
My second letter.
I know it sounds weird, but
That's funny.
speak to it.
Yeah, that's funny. So you know, it's usually when I shave, I don't necessarily when I like to put it in the beard. And that's a good thing I was doing.
And it's also weird how much older it feels on my face.
Yeah.
Yeah. It's a lot.
Yeah. I was thinking about shaking it. Maybe I'll let you do it.
Well, that's why I said I put the chin on, so I'm not going to do it.
Yeah. I'm just gonna let mine rags go wild man.
It looks interesting. It's like that had it's pretty short.
Yeah.
Yeah.
Yeah. This is a long time. And this other chick.
Physics one is closed, but
Sleep at night.
Yeah.
Hey, business or it's not any more work.
I have
Like longer.
all the information, kind of.
Yeah, so like I was on another call. And I had no idea how to do it. And we had open books and
Okay. Just on top or like all the way around? Okay. You always kind of like a similar cut. That's a short set. Yeah, something.
maybe it was the professor.
A little bit shorter on the side, and then for the last bit.
But there's two students. I had,
Okay.
yeah, I had the first time, I got the second way.
Yeah. I growing up, I was a close kid. Okay. So that was about
But like,
Every time I signed up for nursing, it wasn't until
Yeah.
until I got lucky.
Yeah, when you're like, yeah.
I got lucky.
Yeah, my parents were like,
Yeah, because like a lot of.
they get the haircuts. So
They didn't.
I've paid for one haircut. That's easy.
Okay, well, it is great, but they don't think they'll make it here.
Of course.
Too easy.
So, I think last year they did this and then the guy they had to take it down, so anyway, I mean, it's going to take a while. So, I mean, honestly, I can just, kind of waste your time here, make me look bad here and waste your morning, so let's just meet you on Wednesday. And, because I don't think it really makes, I can put it on Zoom and then, but by that time, we're gonna be halfway. So let's just, meet again, please take this with you. And, I'll see you on Wednesday. Hopefully by then,